Hello, this is Dr. Rody, and in this example, I'm going to work through a marginal profit function involving a function that contains a logarithm. We're told here that the cost function for Q units of a certain item is C of Q equals 97Q plus 97. And the revenue function for the same item is R of Q equals the quantity 97Q plus the quantity 54Q divided by natural log of Q. So the first thing it wants us to figure out is, what is the marginal cost? Well, the marginal cost of Q will be the derivative of the cost function. So the derivative of 97Q plus 97 is 97. Part B wants us to find the profit function. So my profit function will be my revenue function minus my cost function. So this becomes 97Q plus 54Q quantity divided by natural log of Q minus, I'm going to put this in parentheses, 97Q plus 97. Now, what I want to do then is to distribute this negative. So 97Q plus the quantity 54Q divided by natural log of Q minus 97Q minus 97. Now notice that when I combine like terms, then my profit function becomes 54Q divided by the natural log of Q minus 97. So then this in here becomes my profit function. Now for part C, it wants the profit from one more unit sold when 8 units are sold. Well, that is the marginal profit, or instantaneous rate of change, at 8 units. They want MP of 8. Well, that is the derivative of the profit function evaluated at 8. So what I first need to do is find P prime of Q, and then once I have P prime of Q, I'll insert 8 and evaluate that function P prime of Q, because the marginal profit is calculated from the derivative. So I need to take the derivative of this function here. Now, I have two parts here. I have the derivative of this part, 54Q or ln of Q, minus the derivative of 97. Now the derivative of a constant is 0. So this part will just be 0 in the derivative. So what I'm going to do is focus on this quotient. And so since I have a quotient, I'm going to use the quotient rule. So I'm going to go over here and just write the quotient rule, just using the VQ notation, UV notation, I should say. So remember, if I have this circumstance and I want its derivative, what you do is, first you do the derivative of the numerator times the denominator, and then you subtract. And I like to put parentheses or grouping just to be careful. I take the derivative of the bottom times, leave the top alone, all divided by the denominator squared, right? So that is our quotient rule. So if I come here, the derivative of 54Q, well, that's 54. And remember, the minus 97 over here is going to become 0. So I'm really focused in on this part. And then I'm going to multiply that by the log of Q. Oops, went the wrong way on that tail. That's a Q, not a G. And then I'm going to subtract the derivative of the denominator. Well, the derivative of ln of Q is 1 over Q, right? d dx of ln of x, that's one of our derivative facts, is 1 over x. So I get 1 over Q times 54Q, which is the numerator here, the function in the numerator, and then all divided by the natural log of Q squared. Well, if I simplify this down, I can think of that as 54 over 1, but those Q's divide out, right? So I get 54 natural log of Q minus 54, because this inside the brackets will simplify to just 54. So 54Q over 1, those divide out. All divide by, and then the natural log of Q squared. So now I just need to find the answer that they're asking for in part C there. Is what we want to do is evaluate P prime of 8. Okay, so I'm going to type this in line, and because of order of operations, I want to put the parentheses so that when I hit divide on the calculator and it makes the slash, it does the subtraction first, then the division. So I'm going to do open parentheses, 54, and then right here next to the 4 is log of 8. Then I'm going to subtract 54, and then I'm going to close parentheses. So that is my numerator. Then I'm going to divide by, open parentheses, the log of 8, and I want that squared, and then close parentheses. So what I've done is I've kind of typed what you can see here, and you know, I was just extra careful to have parentheses to make sure this division goes correctly. And then I hit enter, I get the 13.48. Let's say it's rounded to 2 decimals. So 13.48, I should say 8. I think my brain wanted to do 4 or 5, you know, because they come in order or something. Divided by, dollars per units, right? Those are my, that's my rate of change. If I'm producing 8 units, my instantaneous rate of change or marginal profit at that level is $13.48 per unit. Now, optionally too, in the calculator, you could do math, num, and you can go to the fraction entry, and then you could type in the different pieces of the function on the top, and then on the bottom it's a little small and hard to see, so I like to do it in line. But either way, you have to be aware of order of operations, because the calculator knows order of operations, and you have to be really careful the way you type it in to do it properly. So just be aware of that. If you're using a regular scientific, maybe figure out the logs in pieces and then calculate it out. Anyway, that is an example of how to do a profit function here, marginal profit calculation, when you have a function involving a logarithm.